Welcome to Analog Output. This time we're going to be taking a look at this. What is this? Well, this is sort of a generalized polymorphic synthesizer circuit. So let's say you have an idea for a module you'd like, something that takes a control voltage or 2 or 3 or 4 control voltages and a gate or 2 or 3 or 4, and there's some controls on the front panel, and from all of these it creates an output control voltage or 2 and an output gate or 2. And maybe you can come up with some circuit that does that transformation from the inputs and controls to the outputs. Or maybe you can't, or maybe you don't want to, and you'd rather just do it in software and hand it off to a microcontroller to do the heavy lifting for you. Okay, well, this is fine, but you can't just connect your input and output jacks right to the pins on an Arduino. You can, but it's a bad idea. You don't know what those pins are going to be connected to. The input voltages might be too small, in which case it might not work. They might be too large, in which case they might damage the Arduino. And maybe the outputs produced by the Arduino aren't suitable for sending to the other modules in your system. So on all of your inputs and outputs, you're going to need a few components to condition the signal and make sure it's in the right range of voltage and current. So that's one difficulty. Another difficulty has to do with the output control voltages. The input control voltages aren't a problem as long as they're in the 0 to 5 volt range. You can put those on the analog pins on the Arduino, and they'll go to an onboard analog to digital converter, which will pass the digitized version of the value off to your microcontroller, and you can deal with it, and that's fine. But once that microcontroller has calculated some output voltage it wants to send as a control voltage, there's a problem, because the Arduino does not have an onboard digital to analog converter. You can send analog signals using pulse width modulation, but if you want to use those as control voltages, you're going to have to build an external filter to put those pulse width modulated signals through, and if you do this the easy way, you only get about 8 bits of resolution, which is not very good. Understand that it's possible to get higher resolution pulse width modulation, at least on some Arduinos, but I've never actually found a good explanation, a good clear explanation of how to do it. And anyway, there's another way to do it which I like better, which is to use an external digital to analog converter chip. So these things are not hard to use, and you can easily get, for instance, 12-bit resolution, which is a whole lot better than 8 bits. You do need a voltage reference for the DAC chip, and if you're not too fussy, you can just use the 5 volts from the Arduino, but if you really want good results, it's better to have an actual voltage reference component. The DAC will produce a 0 to 5 volt output voltage. If you want something like a 0 to 10 volt range or a -5 to 5 volt range for your control voltage, then you're going to need an op amp there to do your amplification and level shifting to get to the range you want. So besides the Arduino, you need a DAC, you need a voltage reference, you need an op amp, and you need conditioning components on all the inputs and outputs. So this starts to sound kind of complicated, but once you have all this together on a board, you can have a board that can act as a core of a lot of very different modules, or as one module that can do a lot of different things. So a number of people have pursued ideas like this, and one person named Vincenzo Pacella a few years ago developed such a board and a software library to use with it. He called it Synapse, and he made it an open source project on GitHub. And I saw this project recently, and I thought it was pretty interesting, but there were some things that I kind of wanted to do differently. The biggest thing is that Synapse was designed to be a shield for an Arduino Uno, one of these, and I wanted a board that could be used with an Arduino Nano, which is one of these. I also wanted more inputs than Synapse provided, and there were a few other changes I wanted to make. So I forked the Synapse project and used it as the basis for my own version. So this is it. This is Dakino. And let me just walk you around this circuit because it's really pretty simple and pretty modular. Obviously you have a place to plug in the Arduino Nano here. This is the power input from Eurorack and filtering capacitors and so forth. Here's your digital analog converter chip and the voltage reference and the op amp, which produces the control voltage outputs, which go to these Molex connectors here. And there's Molex connectors over here for the gate inputs. These are the gate input conditioning components, gate outputs here, and control voltage inputs down there. And I put together a circuit diagram for this. I laid out a printed circuit board. I had the printed circuit board fabricated at PCBWay and got it, put it together, tested it, and it did not work. It almost worked. The gate inputs all worked, the gate outputs all worked, the control voltage inputs all worked, control voltage output, not so much. Turned out I had the op amp connected up wrong in the schematic. So redesigned it, laid out the new version of the PC board, had it fabricated PCBWay, they sent it to me, and I assembled it again. This time everything works. So let's take a look. As I said, the circuit's pretty modular, so when I got the corrected circuit board and wanted to make sure that it was corrected, I didn't assemble all of the components. I only put on the Arduino and the ICs and the conditioning components for one control voltage output and tested that. And once I was sure that was going to work, then I was able to go ahead and put the rest of the board together. So let's see the first test. Okay, here we have the board with the Arduino sending control voltage output that's supposed to go from, well, in terms of the numbers it sends out from the Arduino, it's going from 0 to 4095 and back again, just one to the other. So if we look at the output here, we're getting a few millivolts, and then we're getting 10 volts. And like 6 millivolts and 10 volts. Okay, so that's pretty good. So then I populated most of the rest of the board. Actually, I left a couple of bits of it out because I don't anticipate using them with this particular board, but that's okay. You only have to populate whatever inputs and outputs you're actually going to use. And tested that. Alright, so here I've wired up one output and one input of each of gate and control voltage, and right now I'm connected to control voltage output and gate output, and they are both going up to the synthesizer. Control voltage is going through an attenuator over to the VCO, and gate is going to the ADSR. You can already see the ADSR is blinking, and if we listen to what's happening, where is it? Here it is. It's making gates, it's making control voltages, it's doing the right thing, pretty much. For our next test, we're plugged into control voltage in and control voltage out. Control voltage in, I'm just sending it a variable control voltage generated off the Mother 32, and the software is just taking that control voltage in, multiplying it by 4 because the output DAC is 4 times the resolution of the input DAC, ADC, and sending that control voltage back out again, which is going to the VCO. So if we turn it on and then turn the knob, which varies the input control voltage, it reads that input control voltage, sends it to the output, and that goes to the VCO, and it all works. Okay, one more test. We've got gate in coming from the key step, gate out going up to the envelope generator, and there's a known problem in the software where it's getting things backwards on the gate input. I have to fix that, but it's just a software problem. The point is, it's reading no gate from the key step because I'm not pressing a key, and it's sending that, except that it's interpreting that as gate on instead of gate off, and it's sending that to the output, so it's turning the gate on over there. If I press the key, we get a gate, which this thing reads as no gate and sends it to the ADSR. So when I release the key, the light comes on. When I press the key, the light turns off. It's backwards, but that's just software. Hardware is working. Alright, we now have the board with most of it populated. You can see I've left out a little bit here and here, but most of it's there, and I've connected to one of the gate inputs, one of the gate outputs, and one of the CV inputs. And I've got this thing programmed with a modified version of a sketch from the Synapse project, which actually derives from a sketch from the Arducore project. And this is a clock divider. So I've got the input clock also running to one drum module, and I've got the output clock running to another drum module. So if we listen to that, we're hearing this. And now as I turn up the control voltage, we got a 2-to-1 division, now a 4-to-1, 8-to-1, I think I may have skipped 16 and hit 32 there. There's 16. Okay, really simple quantizer. Well, there you have it. You have this board, which is a clock divider. And you have this board, which is a quantizer. And you have this board, which, well, it can be a lot of different things. And I'm pretty excited to be thinking about possibilities for working with this thing. I want to make a nice quantizer out of this. That's one of my next upcoming projects, but there's all sorts of other possibilities. I should mention, as I said before, other people have done stuff like this before. About 10 years ago, there was something called Arducore, which was kind of like this. It used the Arduino Nano and a DAC, and it unfortunately used an 8-bit parallel DAC, 8-bit meaning it didn't have the same quality of output, and parallel meaning it had to use lots of pins on the Arduino, which meant that it couldn't take very many inputs. There's also a module called Tool from Ginkgo Synthez, and there's a very well-known polymorphic module called Disting from Expert Sleepers. So lots of people have done this kind of thing before. Some advantages to this: one is it's open source. Another is that it's based on the Arduino Nano for a more favorable form factor, I think, than the Arduino Uno that the Synapse uses. It's got, as I said, a higher resolution DAC. It's got many more inputs and outputs than most of these things. Based on Synapse, it has one feature I haven't mentioned before, which is that the output can be switched between 0 to 10 volts or -5 to 5 volts. You do that manually with a couple of jumpers here. So what are the downsides? Well, main downside, I think, is the size of this thing. It's not very conducive to putting inside of a Eurorack module. It's about 10 centimeters in each direction. That's like 20 HP module. You could make it smaller. You could use surface mount components. You could maybe make it a sandwich board design, two boards instead of one behind each other, and then it would be more suitable for fitting behind a Eurorack module. It would even be better for the Cosmo format, probably. And if that's something that you would like to do, by all means, go ahead and do it. There's a link down there for the GitHub repository. Go and have a blast. See what you can modify this thing to be. I'll be very interested in seeing. But for me, for the time being, focusing on Cosmo format, the 10 centimeter size is not a major disadvantage. That's what I'll be working with. Anyway, if you want to find out more about what I do with this in the future, or with some of the other projects, there's the subscribe button. Hit the like button, hit the subscribe button, follow Analog Output. There's lots of stuff going on. I'm actually falling behind on the videos. I've got a couple of modules that I've built that I haven't made videos about. I've got a couple more modules that I'm working on. I've got, here, let me show you, parts laid out for a module, which the front panel is down there. And over here, a couple more modules. So yeah, stay tuned. See you next time on Analog Output.